Okay, so hello guys, my name is Sean, and today we're back with another daily video. Today we're solving the Leetcode problem. What are we solving today? Let's see. We're solving a little pressure here because my friends are here, but anyways, it's called add number. I think I've solved this before. Okay, I have solved it before, but we'll see. My laptop, I probably should charge my laptop. 1 second, guys. So we're given a non-empty linked list representing two negative integers. The digits are nodes. The digits are stored in reverse order. Each node contains a single digit. Add the two numbers and return the sum of the linked list. You may assume that the two numbers do not contain any leading zeros except the number 0 itself. Okay, so it's possible that one of them is 0. So I guess we could just check if the head, basically because it's reversed, right? So if the first node is 0, then we can just return L1, and if the so if head, is it possible for the node to be empty? That's the one thing I need to check. So we will have at least the nodes linked list will have 1 to 3. Okay, node of val. Okay, so there will be at least one node. Okay. Number of nodes, okay, at least one. It is guaranteed that the list operation, okay. So when we have a 9, which is what I was thinking, so if we do have 9, we have 9, 9, 9, 9, and we have 9, 9, 9, right? What are we doing here? So this would be 0, carry 1, and so on and so forth. So we kind of need to we do need to reverse the array and go backwards. So what I mean that for this example where we have 2, 4, 3, and then we're doing 5, 6, 4, we need to reverse it so it's 3, 4, 2, and then 4, 6, 7. And we need to kind of have flag if the operation before us was kind of greater than 10, right? Because if we have 9 and 9, that's greater than 10. If we have 9 and if it's greater than or equal to 10, and if it's greater than or equal to 10, we know that the last operation before us is kind of was too big, so we carry a 1 to the next space, right? So the first thing we are going to do is that we're going to reverse the list. Let's reverse the linked list. Right, so we create a prev, create the currents, which is going to equal to, actually we need to reverse both of them actually. So we're actually going to abstract this into a function. We'll call this reverse list. This is going to take in a head. We'll make prev, and currents is going to equal to the head. While there's a currents, we're going to store the temp, which is going to equal to current.next. Make the currents .next be equal to prev, make the prev equal to the currents, make the currents equal to the temp, and then we're going to return the prev. Okay, so now we need to reverse both L1 and now we need a currents 1 and currents 2, which is going to equal to L1 and L2. And while currents and currents 2, because if one of them is shorter than the other, then we just we just add that on its own. What I mean is that if we had something like this, so if we had let's say we had 2, 4, 3, 4, and then the other one was 4, 6, 7. Well, it doesn't matter because remember we're reversing things, right? So it becomes 4, 3, 4, 2, and then this will become, right? This will become 7, 6. Yeah, it becomes 4. It's just a reverse order. What am I? Okay. 4, 6, 7, right? So it becomes 7, 6, 4. 7, 6, 4. Right. So at this point, we have to make sure we check for these kind of cases. So at this point we reverse them, so we will be starting at this node. I have messed up the order, so it'll be this way actually. Yeah, it'll be this way. So now we kind of have them reversed like this, and then we are gonna do like the we're gonna add up to this point and like kind of yeah. So we will be creating a new. It's gonna be linear space, linear time. We'll create a res, which is gonna equal to a list node. Oh, I forgot to time myself. Oh. Yeah, so it is possible. So it's possible that the two nodes. Oh wait, because this loop would never happen, right? Okay, so yeah. So while there's a core 1, right, you want to get the current val, and then yeah. So we need some kind of way. We need some kind of dummy pointer that's gonna help us build our list. Right. Alright, so we're gonna say calc. No, should I just call it sol is gonna equal to num2 plus num1 plus num2. If the sol is greater than or equal to 10, then we need to kind of turn on a flag, right? We're gonna have some kind of flag here. It's gonna equal to false. So this is gonna equal to true, and flag is gonna equal to true. Alright, what do we want to do here? So in this case, when it's greater than or equal to 10, we actually want the res.next to equal. Yeah, so we want to actually create the new node. So we're going to create. Yeah, so in this case, we would actually create the node, but the question is. Yeah, so we'll create the new node after. So we'll always just create the new node. It's going to equal to a list node. It's going to be like a random number for now. If it is this, then we're gonna that new node's .val is gonna equal to 0, and then else the new node .val is gonna equal to the solution. Then, for all the cases, we're gonna make sure that the dummy .next is gonna equal to the new node. We're gonna update our dummy to equal to dummy.next. Yeah, we also need to make sure we update the pointers. So current 1 is going to equal to current 1.next. Current 2 is going to equal to current 2.next. So what happens when we've done this, right? So so if there is a flag, right? So we have to make sure if there is a flag, we're kind of adding 1 to the results. So we need to check if flag. We need to make sure we do sol plus equal 1. We're going to set the flag back to 0, back to false, and then kind of simulate like the results adding. We've moved to the next bit basically. Yeah, so once we do that, we add 2 to 5. Wait, what's reversing? Yeah, we need to reverse because then it'll become 3, 4. So we do this, become 8. We go to the next iteration. This is going to be 0. So we put 0 in here. So it's actually going to be 0. Then we turn the flag on, and then we come here. It will be 2 plus 5, which would be 7. Oh, but that should be 8. Wait, what? That's 0 and then it carried. Am I being stupid? Because bro, Ronnie, I'm recording a YouTube video right now. You can come and say hi if you want. YouTube. Um, this is gonna be. Wait, am I bugging? Wait, why is that the case? Oh wait, it's the other way round. It goes to the right. What? Oh, that changes everything. So just don't need to reverse. Yeah, so we kind of want to do this, right? So we actually start at the beginning, actually. We don't want to reverse the list because it goes to the right. I don't know why it was left to right. I was thinking like actual addition. Yeah, so if this happens, yeah, so what are we doing here? Yeah, so it's from left to right. So in this case, we'll have 999. So this 9 plus 9 will become 18. What? This is 7. This is 0, carry 1. Yeah, then, yeah, so then in this situation, what is it? It's 9 plus 9, which is 18. Shouldn't that be 1? Yeah, it's... Oh, no. $18. Oh, right. It's, sorry, it's actually not 0. It's gonna be... So if it's 18, it'll be 10. So this will actually be 8. Yeah. Okay. And then, yeah, we keep on going. While there's a core 1, we're still going to make sure to just do this. Now, to make sure we actually do update current. Yeah, we have to also make sure the flag thing, if the flag is on, we also have to account for that, but I'll do that in a second. Yeah, so we do the same thing. So if there's a flag, yeah, so sol is going to equal to current1 dot val. If there's a flag, we do sol plus equal 1. If sol is greater than or equal to 10, what are we doing here? We are flag is going to equal, so yeah, we have to make sure return flag to equal to false. Flag is going to equal back to true. You guys, I'm almost done, by the way. Yeah. So we basically just want to do the exact same thing again, but for card 2. that should be it. Indentation error. Well, I need to stop doing that. Just don't indent. Hopefully it should work. Oh my, wait, what? Can I, oh, wait, what the hell? Oh my god, making those mistakes. Okay, so 708. So I think it's for that last thing. So if I print the flag, if there's an addition, if it's true, that means you need to add a 1. Okay, so that's the last thing. So the flag is true. Then we want the dummy done next to equal to a new list node with 1. Yep, I think that should be correct. We're kind of like simulating addition basically. Yeah, I think that should be everything. Let's give it a nice submit. Hopefully it works so I can go. Let's go. Okay. If you guys enjoyed today's solution, yeah. Wait, did it work? I can't even see the thing. Okay, yeah. So if you guys enjoyed today's solution, please remember to like and subscribe. Yeah, I'll see you guys in the next one. I'm actually at university right now. By the way, we also won our pitch. By the way, we won our pitch, guys. So we just won £500, but yeah. Anyways, hope you guys have a good day. Remember to pray, keep on grinding, and yeah, see you guys. Peace.